Hi dear students, how are you? Hope all of you are fine. Today I am going to discuss about diffusion and diffusion rate, diffusion time. This is second chapter, states of matter. Okay. First, what is diffusion? I am telling the definition of diffusion. The tendency of solid, liquid or gas to spread spontaneously and uniformly in any medium is called diffusion. Uniformly it will be spread out. Consider perfume. We usually use perfume. If you press the nozzle, then perfume will be spread out. If we keep any person to check the smell of the perfume, then it will take few seconds to go there. Suppose if you press the bottle, then 2 meters away, if any person is there to check the smell, then a certain time he will get the smell. So it will take fixed time for spreading out. When the perfume is sprayed in the room, the particles mix with the molecule of the air and they are moving around quickly and randomly. Now another example of diffusion. This is potassium permanganate. If I put a small amount of potassium permanganate in the water, then it will be spread out within a certain time. So let's get started and see what will be happened. I have just put a small amount of potassium permanganate. Then it is being spread out whole the bottle. That means in the water it is getting mixed. So a certain time the whole water will be colored. So this is the perfect example of diffusion. Similarly, consider different types of gases: methane, oxygen, hydrogen, and nitrogen. Even there are many gases, sulfur dioxide, nitrogen dioxide, and many other gases. You can consider any of these. Now we are considering oxygen. Oxygen. So, how it will spread out? Even you can consider nitrogen. Between two gases, which one will spread out quickly, which one will take less time to spread out? So it depends on its molar mass, molecular mass. Based on the atomic mass, we can find out the molecular mass of oxygen and nitrogen. Even there are many gases like methane, sulfur dioxide, nitrogen dioxide, and hydrogen, and ethane, and any type of gas you can take an example. Okay, so we are discussing sulfur dioxide and nitrogen dioxide. Okay, what's the molecular mass? We'll find out first. Nitrogen dioxide. One nitrogen atom and two oxygen atom. So atomic mass of nitrogen is 14 and atomic mass of oxygen is 16. And how many atoms are there? 2. So we'll multiply 16 by 2. So finally 14 plus 32 equal to 46. This is the molar mass of nitrogen dioxide. Consider sulfur dioxide. How many atoms are there? There are 3 atoms. One is sulfur, another is oxygen. So, sulfur, what's the atomic mass of sulfur? What's the atomic mass of sulfur? This is 32 plus. What's the atomic mass of oxygen? We know we have already written here, this is 16. So, 16 into 2, so 32 plus here 32 equal to 64. So this is molar mass or molecular mass of nitrogen dioxide and this is the molar mass of sulfur dioxide. Here 46 is smaller than 64. Actually the spreading out of any gas totally depends on molecular mass. How it depends? We know rate of diffusion. It depends on density or it depends on molar mass. That means rate is inversely proportional of root of molecular mass or density. We know there is a relation between molecular mass and density, and this is d or density equal to m divided by 2. So you can take any one to explain this. So we are taking molecular mass for description. R varies 1 by root over m. Consider R equal to constant k and 1 by root over m. Suppose this value k equal to 1. K equal to 1. So what's the value of R here? Equal to R equal to 1 by root over m. Okay. So consider, just we are giving an example. Molecular mass of any gas is 4. Suppose this is m1 equal to 4 and another gas has molecular mass equal to 1. Suppose. So for this case R equal to k. That means we have got here value of k is 1. So it will be 1 by root over m1. Suppose it is R1. So or it will be 1 by root over 4. So finally 1 by 2, that means 0.5. So value of R1 equal to 0.5 and another one, this one is 1. So consider for this R2 equal to 1 by root over m here. So 1 by root over m, it is 2. So 1 by root over 1, that means 1 by 1 equal to 1. Look, here m equal to 4, m1 and m2 equal to here 1. So for this gas, first gas, we have got rate 0.5 and for second gas, we have got here 1. That means value of molecular mass is bigger but rate is smaller. That means when we have got bigger number as molar mass, that means m1, when m1 equal to 4, we have got R1 equal to 0.5. And when m2 equal to 1, here R2 equal to 1. Molecular mass of first gas is bigger than m2, but the rate R1, but R1 is smaller than R2. Look, M1 is greater, R1 is smaller. M1 is smaller, R1 is greater. That means when molecular mass is bigger, then the rate is smaller. For 4 we have got here 0.5 and for 1 we have got 1. That means it is proved when molecular mass is bigger, then rate is smaller. Diffusion rate is smaller when molecular mass is bigger, but when molecular mass is smaller, then the rate is bigger. So if R1 is smaller and R2 is bigger, then how much time, which gas will take less time? For first gas, R1 is smaller, that means rate is smaller or less. So time, which gas will take less time? Value of R2 is greater, that means it will take less time. But value of R1 is smaller, that means it will take more time. Now again we are going for sulfur dioxide and nitrogen dioxide. Sulfur dioxide. For sulfur dioxide, molecular mass of sulfur dioxide is 64 and nitrogen dioxide the molecular mass of 46. That means this is the bigger value than this. So diffusion rate will be less for this, and diffusion rate for nitrogen dioxide will be more. So we can tell that the diffusion rate of sulfur dioxide, if I tell R sulfur dioxide, since the value of molecular mass is bigger, so it will be smaller. And R nitrogen dioxide, the molecular mass of nitrogen dioxide is 46, that means less than 64. So the rate of nitrogen dioxide will be bigger. So if I consider about time, R for sulfur dioxide, it is molar. So time for sulfur dioxide, that means spreading time, or how much time it will take. Rate is molar, that means it will take more time. But rate for nitrogen dioxide is greater or more, so it will take less time. When molecular mass is greater, then the diffusion rate is smaller. If I give now only oxygen and nitrogen, for nitrogen, for oxygen it will be 16 into 2 equal to 32, and for nitrogen molecule it will be 14 into 2 equal to 28. So 32 is more than 28. So molecular mass of oxygen equal to 32. So diffusion rate will be less. So we can conclude by telling that molecular mass of oxygen is 32. That means a greater value than molecular mass of nitrogen. So diffusion rate is smaller, and molecular mass of nitrogen is less than 32. So diffusion rate will be bigger. So diffusion rate is bigger, that means it will take less time. So I think you can find out diffusion rate for methane, for ethane, CH3. If I tell ammonia, so for any type of gas, you can compare by finding out the molecular mass of the gases. So today up to this. Thank you for watching.